People are always telling me when it comes to building serverless applications, the developer experience on Azure is just so much better. So I've got my Azure functions defined now, and actually I kind of like this is a lot better. I've got my functions defined, all my configuration is defined in code. I've got my 4 API endpoints from my product API, all defined as HTTP triggers with the various methods and the various routes. All of this stuff also connects to a Postgres database behind the scenes. Now I just want to run this whole thing locally and test everything works before I push it up to Azure. Now where is that debug button that makes sure I've got my Azure functions running and my database connection passed in as well? How can I even debug all of this locally? How can I even make sure that all of this works before pushing to Azure? Maybe I should have just built this damn thing with ASP.NET. The developer experience is better on Azure? Says who? Hi, I'm James Eastham, and in this video you're going to learn how you can leverage .NET Aspire to dramatically improve the local developer experience for building serverless applications on Azure. Now, I was the first person to be critical of .NET Aspire when it was first announced, a tool that makes it incredibly easy to build distributed monoliths. I can set up a bunch of microservices, I can wire them all together in .NET Aspire and then right-click publish and everything's running in the cloud without a care in the world. Honestly, not a particularly good idea. But if you think about .NET Aspire as a way to simply run various different applications and the required resources alongside them locally, I mean that is a pretty good thing, as long as you have them really hard boundaries that you don't end up running multiple different microservices all together at the same time, because, well, that kind of breaks the core idea of microservices. But if you think about it as a replacement for Docker Compose, a replacement that means you can write .NET instead of YAML. And I mean, I'm sure none of you like writing YAML, do you? It's a powerful tool because it means you can set up and test your application locally with full debugging support, as well as any additional resources that your application might need or rely on, things like a Postgres database, or maybe you're emulating Azure Service Bus locally. This becomes all the more important when you're working with something like Azure Functions. Whereas historically you might have had a single ASP.NET project that you just hit debug inside your IDE and everything just starts up and runs locally, Azure Functions are made up of lots of smaller individual functions that all come together to make up your entire application. Think about a typical CRUD API. You've got a create endpoint, a read endpoint, an update endpoint, and a delete endpoint. In the ASP.NET world, that would be a single ASP.NET Web API with 4, 5, maybe 5 endpoints. Azure Functions, that is going to be 4 separate functions running inside the same function app. Plus you've got some kind of database or backend store to connect that to. So how would you actually go about using Aspire with Azure Functions? Well, thankfully, there is a preview package that allows you to integrate Azure Functions with .NET Aspire. It supports a variety of different Azure Function triggers, event hubs, service bus, queues, HTTP, timers, HTTP being the one that's most useful for our video today. The first thing you need to do is add an Aspire hosting Azure Functions NuGet package. Again, this is still in beta, so you need to add the pre-release flag, and then you can actually configure your Azure Functions project inside your Aspire application. But enough of looking at docs. All the code for this sample is available on GitHub. There's a link in the description below. And we'll start off just by having a quick look at the Azure Functions project itself. There's not an awful lot going on here. There's just 5 different API endpoints, one of those being a health check, which ensures that the database is created. And then you've got a list, a get, a create, and a delete endpoint. All of these are mapped up using HTTP triggers with the relevant method and route defined as part of that attribute. There's not an awful lot to care about as far as the actual application code goes. You've got them 4 or 5 endpoints, and then you've got a Postgres database sat behind the scenes, which is accessed with Entity Framework. Let's have a look at the Aspire stuff though, where things start to get really interesting. And let's first have a look at the actual NuGet packages that have been installed on this project. And you'll notice you've got the Aspire hosting Azure Functions. This is the preview version because this is still in beta. You've also got the Aspire hosting Postgres SQL, which is an Aspire extension that allows you to actually run Postgres as part of Aspire. They're the 2 things we need for this application. We need an Azure function and we need a Postgres database. So let's actually have a look at the program.cs file. So we create our distributed application and we add Postgres. This add Postgres extension method comes from that Aspire hosting Postgres SQL NuGet package that you've just seen. You can give your Postgres instance a name, and you can also automatically add a database to that Postgres instance as well. So I'm going to add a database called products. Then this with lifetime method ensures that the Postgres database stays running between starting and stopping your Aspire project. Postgres can take a little bit of time to start up, so using this with lifetime ensures that between starting and stopping your application during the development cycle, you're not waiting for Postgres to start up anytime. I'm then going to actually emulate Azure storage locally as well. So I can call this add Azure storage method on my builder to just create a local emulated Azure storage account that is useful for when I call add Azure functions, because I can then say use this local emulated Azure storage when I'm actually running Azure functions locally as well. So now everything is self-contained inside my local machine. When you call this add Azure functions project, you pass in the Azure functions project that you've referenced in your Aspire project, giving that running thing a name. I'm going to call this functions. And then finally, I'm going to use this with environment extension method to actually set an environment variable on my running functions. I'm going to set an environment variable called connection string. This is what my actual application is looking for when it connects to Postgres. And I'm going to pass in the database resource that was created up at the top here. When you pass in the resource to this with environment method, that is going to automatically extract the connection string and set the connection string on this connection string environment variable. And then finally, I'm going to expose some HTTP endpoints. Now that you've got all of that configured, let's actually see if this works. So I'm going to come back over to my actual Azure function project, and I'm going to have a look at my list products endpoint, which is up here somewhere. And I'm going to set a breakpoint on list products, and then I'm going to make sure I'm running my Azure. And then I'm going to start the debugger. Once the debugger starts, that's going to automatically load me into a web browser logged into the Aspire dashboard. And you'll see I've got my Postgres database. You'll see I've got my Postgres server with my products database underneath that. I've got my locally emulated Azure storage, and then I've got my actual Azure function project. If you go and have a look at the Azure function project and have a look at the connection string environment variable, you'll see that this is the connection string for that locally running instance of Postgres. From here, now I can actually hit my API endpoint. So I'm going to open up that local URL, and then just to double check exactly what my route is. So it's a get to /products. So Azure Functions automatically prefixes /API. So if I go /API/products, I hit my breakpoint back in Rider, and I can actually step through my application code, which should return me nothing. There's a problem. There's a problem because I've not actually ran my database migrations. So I'm going to come back up here and just run the health endpoint. That's going to then return okay. Hit products again this second time, and it now returns successfully. So if you are running this locally, just make sure you hit that health check endpoint first to make sure that the database actually gets created. And that is that. You've now got the ability to run Azure Functions locally, to run all of the required infrastructure alongside your Azure Functions, and treat your Azure Functions project as the single application that it is, made up of a collection of these individual Azure Functions. Of course, this isn't always foolproof though. Whilst this does allow you to debug your application code, it doesn't allow you to debug things like the permissions your Azure Function has, or whether you've correctly configured the Azure Function app with all the right settings, all the right environment variables, or even if your application starts up inside Azure. You're testing locally here. Generally, I would recommend when you're building serverless applications to test in the cloud rather than trying to run the cloud locally on your machine. But when you've got these services that are fully supported by Azure, you've got this Azure function extension, you've got .NET Aspire that are Azure, that are Microsoft built projects, I think this is a worthwhile trade-off. Now, whilst in this video you've only seen HTTP triggers, one of the biggest superpowers of Azure Functions is its ability to react to events, to dynamically scale up and down and deal with things in a more event-driven way, should we say. Whether that's responding to events sent to Azure Service Bus, Event Grid, or running things on a schedule. How do you test that kind of stuff? How do you work with these functions that aren't just dealing with API requests, that are actually dealing with events published to other managed Azure services? Interested in that? Don't worry, you'll find about all of that and more in the next video. I'll see you all there.